Solving quadratic equations. These are some of the methods that we've looked at for solving quadratic equations. We've looked at factoring out, factoring difference of squares, factoring perfect square trinomials, factoring trinomials, and completing the square was the most recent one. So when we're solving, for example, in the factoring out example, I would factor out a 4x. I'd be left with x minus 5. Now, because their product equals 0, that means either one of these factors could be equal to 0, or they both could be. So we have to solve for both cases. So we solve for 4x equal to 0. We would get x equals 0, and x minus 5 equals 0, where x would equal 5. So that's how we would get our two solutions if we were factoring out. Let's look at factoring the difference of squares. When we factor the difference of squares, we get, for this one, we would get x plus 6 and x minus 6. But then again, still, their product is 0. So we have to check each one and set it equal to 0. It's not really a check, it's a final step. So here we would get, we subtract 6 from both sides, we get that x equals negative 6. And here we add 6 to both sides, and we get that x equals 6. So those would be our two solutions. Let's look at factoring perfect square trinomials. This perfect square trinomial would factor to x minus 4 squared, which means we'd have x minus 4 equals 0 and x minus 4 equals 0. Now, there's not really any point in solving the same thing twice, but it does mean that we're going to have only one solution for our trinomial, where normally we have two. Let's look at factoring trinomials when we have ax squared, bx, and c. So in this type of problem, we multiplied the first and last terms, and we get negative 12. And we looked for two numbers that multiply to be negative 12, but add to be negative 1. So two numbers that I could think of would be negative 4 and a positive 3. So we replace the middle term with those two numbers. We have 3x squared minus 4x plus 3x minus 4. So this middle term got replaced with the two terms that we found, negative 4x and positive 3x. And now we're going to group. We're going to group these first two together and these last two together, and we're going to pull out. So in the first one, I can factor out or pull out an x, and I'm left with 3x minus 4. If I want to be left with the same thing here, it looks like I don't need to do anything, right? Because that's already what I've got. So I'll factor out a 1. Because that's the same thing as not doing anything. It's dividing by 1. It's the identity. So I take the two that were factored out and I put them together. And I take the factor that was repeated and I just have to write it one time now. It's kind of like undistributing. But like in all the other examples, their product is equal to 0, so I still have to set each factor equal to 0 and solve. Here I'll get negative 1. Here I'll get 4/3. And that would give me my two solutions. This last one is probably the most fresh in your mind because we just did completing the square in the last lesson. So I have to take this negative 15 and move it over. I have x squared minus 6x. I'm going to leave a space. And you know why I'm leaving that space? Because I'm going to take my middle term, which is negative 6. I'm going to divide it by 2, which is negative 3. and I'm going to square it. And that's what gives me my third term of the trinomial, which is positive 9. But I can't just do it to one side, I have to do it to both, so I add 9 on the other side. On the left, I can rewrite as my squared binomial. On the right, I've got to combine like terms, and I get 24. So I'm at the step now where I have to take the square root of both sides, because that's the only way I'm going to get rid of that binomial being squared. When I do that, I have x minus 3 equals plus or minus the square root of 24. Now, the square root of 24 can be rewritten as 4 times 6, right? Or better yet, square root of 4 times square root of 6. And the square root of 4 is 2. So I can rewrite this as x minus 3 equals plus or minus 2 root 6. Almost done. Now I need to move that minus 3 from the left side to the right side. So I get that x equals 3 plus or minus 2 root 6. And those are two solutions, even though it just looks like one. But then I would still, actually here, I don't have to set equal to 0 for each of my factors, because in completing the square, I did set it equal to 0 already and solved. So then I'm done with completing the square. So these are 5 different methods that we've looked at so far. And it would be nice to know what type of answer I'm going to get. Like in all of these, here I got 2 rational answers, and here as well, and here as well. Rational means it's either an integer or a fraction. Now down here, I only got 1 rational solution, and here I got 2 irrational solutions. So it would be nice to know what type of solution I should get before I solve. And the way that we can do that is by using the discriminant.